So, right here, number 12.
Okay. So we got a solid disc with a diameter of 3.2 meters and a mass of 42 rolls without slipping at the bottom of a hill starting from rest. The angular speed of the disc is 4.2 radians per second at the bottom. How high did it start on the hill? Okay. Alright, let's see. So you have like this disc, right?
Yep.
And it's rolling down the hill. So it wants to know how high did this thing start, right?
Yeah.
So what's H? Okay, so let me use this. Okay, so what do we know? We know angular velocity at the bottom.
4.27 radians per second.
Okay.
And then we have the radius of the disc or whatever is 1.6 meters.
Okay.
And then its mass is 42 kilograms. And we need to see how high it started.
Okay. So if I'm like just holding this thing here, it's not moving, what kind of energy?
Potential.
Yep, right. So it's got potential here, up here. And then down here at the bottom, it has what?
Would it just be just kinetic energy?
Yep, there's kinetic. But it has, so when we're talking about something that's like it's rolling like this, it's gonna have two types of kinetic energy. So it's gonna have the translational, and it's gonna have like rotational as well.
Okay.
So we're gonna say our potential energy is equal to the kinetic energy, like it's translational, right? And then it's rotational as well. So potential energy, we got our mass times gravity times height, right?
Yeah.
And our kinetic energy of 1/2 mass times velocity squared. Plus we have our 1/2 moment of inertia times angular velocity squared.
Okay.
Okay, so moment of inertia, it says it's a disk, right?
Yeah, a solid uniform disk.
Okay, so so solid uniform disk, its moment of inertia is going to be 1/2 mr squared.
Okay.
So let's solve for that real quick. So our mass of 42, and our 1.6 squared.
53.76.
Okay, so that's our moment of inertia, right?
Okay.
So that's out of the way. This, we already know. Okay, so we could get all of this. Mass, we know that. Okay, we want to solve for our velocity though. So, velocity is just
And then just
angular
times the
Yep,
radius.
yeah, exactly. So, well, we could just plug that in here, right? Okay, so if we just start basically, we just can plug in numbers until, so we got like our 42 kilograms, 9.8, we got our height, 1/2 our 42, times our velocity, which is going to be our 4.27 times 1.6, and all of that squared. Then we add our 1/2 moment of inertia, which we solve for 53.7, and then times our angular. And make sure you square that guy. I'm running out of room, but.
Okay.
So then once you solve for the, like you just multiply this out, add it together, divide by this.
And why is it the potential energy equals the kinetic energy plus the kinetic energy of rotational?
So before we just talked about like blocks sliding down hills and stuff,
Yeah.
right? So it didn't have any, it's just translational. But now it has two types of kinetic energy at the bottom here. And so to get like, so really it looks like this. That's kind of how you're used to seeing
Yeah,
it.
yeah.
This is just total kinetic energy. So the kinetic energy total, which is that, is equal to its translational plus its like rotational.
That's for something that's rolling.
Yup, yeah.
And like
Right,
rolling
yeah.
and moving forward
Yep.
or whatever.
Because it still has velocity, but now it has like a moment of inertia and angular velocity as well.
Okay.
So you have to take into account both
Okay.
kinetic energies, which is why you do both
Yeah.
of them there.
Okay.
Yeah. So. But yeah, anyways, then you just solve for height.